Hey guys, I'm Malya, President of Tejas India Foundation, and our entire team in Tejas India and TZ APEC in Asia Pacific are really looking forward to what kind of projects you build using Tejas Python SDKs. Thank you guys.
Thank you. Thank you. Good morning. How's everybody? I hope you enjoy Python APEC 2020. For these sessions, we have our guest Keith Packard over here, and we'd like to have a session with him talking, sharing experience of being open source software developers. So first, I'd like to have a short introductory about Keith. So Keith has been developing free software since 1986 and working on the X Window system. And for those who does not know what is X Window system is the basic building blocks for all the desktop GUI that you see, including Genome, KDE, and many more that you use daily for your Linux laptop. And apart from that, he's also an amateur rocketry and educational robotics. He is also currently a principal engineer at SiFive. Has been taught computer programming to students from age 10 to 17 using Lego robotics over 15 years, and he started Snek Language project that is used for the teaching right now. Now, a little bit story about these Snek projects over here. I encountered Snek when I was looking around at the webpage for the PyCon Cascade, which is hosted in Portland that time. So when I look at it, I found something interesting about this word Snek. So this is why I I started to have communication with Keith and find out that the project is interesting. So this is something that story that I know about Keith. And apart from that, he also received an award from Usenet Lifetime Achievement in 1999, and as well as O'Reilly Open Source Award in 2011. Okay, and currently he's also S.org Foundation Board. Okay, Keith, good morning.
Good evening.
Yep. Oh, okay. Yep. Okay.
We can go the other way too. Good morning,
Yeah,
James.
the other way around. Yeah, that's okay. I already got confused with that, even though yep. So speaking of the X.org, of course, we know that before that we have X386, which is early days for those who have been using Linux for since 80s or no 90s, 2000. Like my case, 2000 when I first installed my Red Hat 7.1, I encountered this X386. So one thing that I find out interesting on that is, so now reading all the histories from the GUI development, we know that Cirrus Alto has been the first one came out with that, and since then MIT X Consortium also started this project on building out the GUI and that. So since you started working with Microsoft X Consortium, would you like to share a little bit of the developments of the GUI throughout the from Cirrus all the way to how MIT started the X Consortium on this GUI project on Unix system?
Sure. So as you told us, Xerox PARC, a bunch of people worked on a system called Alto in the mid 1970s. So that's a long time ago now, 45 years ago now. And they were kind of building the future of computing. They introduced the first mouse. They put together the first bitmap graphics environment. And they developed the first object-oriented language, Smalltalk, in that world. Not the first one, but kind of the first really all the way down to the metal object-oriented system called Smalltalk. And after that, everybody looked at that and said, "Well, we want some of that." I think the adoption into Apple is very well known, where Steve Jobs actually went to Xerox PARC and learned about that system. In the early 1980s, at Stanford, which is very close to Xerox PARC in the same town, the Stanford researchers were building a system called the V kernel, or the V system, which is a distributed multi-kernel, multi-machine operating system environment. They built a Windows system called W. And that was really the starting of X. X is a port of W from the V kernel to Unix. And it was done by researchers working with Barbara Liskov, Bob Scheifler at MIT. And all that they wanted to do was have multiple terminals on the screen simultaneously, so they could debug their multi-distributed Argus programs. So the very notion of a GUI with fancy bitmaps and a mouse and all that kind of stuff was the furthest thing from their mind. They just wanted multiple X terms, effectively. And so it really is a very humble beginning to the Windows system that we use on Unix today. But it took probably 5 years after that initial notion for people to understand that those humble beginnings could build a much more sophisticated graphical environment capable of reproducing the kinds of environments they were doing at Xerox PARC.
Okay, cool. There's one question that came up with from my mind, and we know that X386 or X.org nowadays you still kind of use the server and client models rather than well, maybe I'm wrong, but is there any reasons why you adopt the server and client models rather than you have your GUIs directly talking to the kernel? This is my doubts as as a knob for using Linux
It's
system
kind of
for a
funny
while.
because so there were some kernel-based Windows systems back in the old days. SunView was the first Sun Windows system. It was kernel-based. But after that, most Windows systems that you use today are client-server based. So
Okay.
Microsoft NT has a Windows system server. Apple has a Windows system server. Even on Android, there are effectively Windows system services inside the operating system that perform much the same role as the X Windows system server does. And it's important to realize that much of the Windows system's role in your computer is to multiplex all of your applications to a single screen and
Mhm.
demultiplex the input from the human user from a single device to multiple applications. And that has a lot of very tightly coupled state between those two systems. And putting that in a single executable with a single memory space is tremendously eases the engineering effort. And so many systems use the same model. We use that on the web today, right? We put our web
Yep.
servers,
Yep.
And then we have a simple client on the, well, not so simple today, but it used to be a simple client on the desktop. And a lot of that is just to ease the implementation and to make it more secure and more stable. So the client server model is an easy paradigm for people to understand, and an easy way to implement a system. And as long as you create an effective and efficient protocol for transmitting the correct information between the two halves, it's very efficient as well. X has not always been the best way of transmitting information. And it's only recently, probably within the last 15 years, that X has really gotten to the point where it is a very efficient Windows system by using kernel communication capabilities added to the Linux kernel within the last 20 years or so to make it so that the Windows system is doing just the Windows system job and not also the graphics system job.
Okay. Another question that actually came out of the, during your time in X386, and one thing is that you have your concern over the project management, which is, you mentioned that as this is more like a cathedral style, and that might hinders a little bit of or delays the progress of a projects over there. So as an implication of that question, what would your advice or maybe recommendation for current open source project management, so that it still makes the delivery while it doesn't hurt the relations between the team members? Because because on your concern, that is more on the relations between the team members as well as the management as well as the delivery of the projects in your previous concern with X386. So this is my question over there.
Yeah, I think the most important thing is that the management of the project be a representative of the community that it serves. That the community have the ability to elect the management, the leadership of the project, and that leadership regularly come up for a vote of the entire community. Probably the model that I've used a lot in the organizations that I've built is the one that GNOME first taught me. Where the community is defined by the people who say that they are members of the community and demonstrate some commitment by contributing in any way, not just code, but code, running conferences like you yourself are doing here, doing documentation, testing, evangelizing, teaching. All of these are ways of being members of the community, and all of those people should be participating in a democratic election of the leaders of the project. So organizations like the original X386, which did not have a democratically elected representation, or organizations like the Free Software Foundation today, which do not democratically elect their leaders. These are examples of organizations that have a hard time representing their members, accurately. So Python is doing a very good job in that area, and it has a good leadership that is represented to the community.
Perhaps in this way, since you mentioned about the democratically elected members over there, so since you mentioned about Free Software Foundation, that the chair has not been elected for a while, so I wonder how does let's say if you have not have elected members on it or been practicing democratics in your organization over there, how does that reflects on your the principles or the mottos or the visions of the organizations? So that's my question over there. Yeah.
So when the leadership is democratically elected by the members, then the leadership has to respond to the needs of the members in broad. Of course, you have to combine that with a strong constitutional requirement that there be rights of the organizational members. And certainly a lot of organizations have adopted strong codes of conduct, which are very important to making sure that the members feel safe in the organization. But just the combination of good rights for the members and leadership that comes from the membership and is responsible to the membership directly.
Yeah. Okay. Partly is because well, the reason for me to have this question pop out just for the audience to know, because recently, if you have read news, Free Software Foundation's one of the previous chair has involved in some issues, which I don't really want to mention it over here. So if you are interested, you can read it. And this is why, I mean, like Keith had mentioned, that PSF had done quite a job in, keeping the terms for the board members, so that you have new elected members to join them and then have different perspective in running the organizations. Okay. So next question that I would like to ask about Keith, that is, throughout your histories of your career over there, so you seem to have involved in different kinds of open source projects of that. And perhaps this is a question that I'd like to ask on behalf of the audience. What is your most cherished moment and also your setbacks when working with open source projects?
Well, certainly the best times I have with open source projects is when working with developers successfully getting their contributions integrated into the project and seeing the joy and delight that they have on succeeding in a new project. That's always a fantastic thing. So to have new developers come into a project and start actively contributing is a tremendous source of delight. And obviously, the contrast to that is when developers feel they need to leave the community as a result of technical division or personal strife. That's always very difficult. Certainly in the Debian community, the struggle that we had over an initialization system was very painful for all of us in that community, and we still don't like it.
Okay, well, of course, for every communities, we know that sometimes volunteers come and go. So in terms of that, sometimes, when somebody, let's say the volunteers left, and then he has some, jobs that or tasks has not been completed. So, like your experience, probably you have seen that. So how would you advise on this kind of issue? Like how do we have a handover? And probably in the case that when the handover was not done, in a very, well, I'll say beautifully in a way, maybe maybe it has some damage over there, so what would be your advice to us in mitigate this kind of situation so that we keep the damage to the lowest as possible?
I think the main thing is during the process of any heated technical discussion is to try to keep personal relationships safe, to try to make sure that people feel safe to come or go. It's important to let people know that if they don't feel like they can contribute actively to a project anymore, that they are safe to leave and that the project will still continue on without them. And to let them know that there are processes for how to stop contributing to a project. Debian actually has a pretty good process there in having a very formal mechanism for resigning from the project and for ceding over responsibility for the portions of the system that individual developers were working on. And making sure that those are available for other people to adopt. So that's a pretty good model where there's a list of packages that are needed, that need people to be maintaining them, so that people know they can come in and take them up, so that they aren't just hanging in limbo. So that each project, each package in Debian has a well-defined set of maintainers who are active Debian developers, and we have a process for discovering when developers are no longer contributing, trying to contact them and reassigning their packages to other developers who are willing to take up the slack.
A very good advice for all of us. For us who works with open source projects, we do have sometimes we do have this kind of project. And what a good things that you mentioned about Debian over there is a proper and nice documented handover process will be helpful in a way that help us to hand over projects B2B when you're resigning or when you're joining the projects, and that would be something that would be good for us to adopt that in open source project, because right now open source project that we encounter over here in maybe in Asia or maybe some other parts in Asia, we just started with this, and probably we are still looking around on how we can contribute and how to get a community over that. So this is why this turned out to be interesting to know how Debian works in this case. Now, of course, we'd like to know one thing about snakes, and one question that I'd like to ask about is a question that I read after I read this biography by Steve Wozniak, as I mentioned before. Steve Wozniak, after he left Apple's, he taught Kick's programming. So, and looking at what you have doing right now, you seems like you're also teaching the Kicks after you kind of have retired in a way from the main programming software business. So I wonder what motivates you to teach Kicks programming.
It's a lot of fun, actually, getting to play with kids, a long sequence of kids and have a relationship with a lot of different students is a delightful thing to do. And so the energy they bring and the questions they have are always intriguing. We run the same curriculum through a lot of different students, and every year I'm surprised at the questions the children have, and the way they solve problems are often very unique. I get to learn a lot about how programming is learned by new students, which is a great way for me to learn more about how to teach programming better. So it's a fun learning opportunity for me, as well as an opportunity to share some of the things that I've learned with a new generation of students and watch them grow as they learn things through the program. A lot of the students we work with, because we work with both students and student mentors. I've worked with some students for as long as 6 or 8 years, and so I get to see them grow up just as I watch my own children grow up. So a lot of the same joy that you get from raising children, you get in teaching as well. So I certainly enjoyed that. I learned a lot about why one might teach from people like Alan Kay, who started at Xerox PARC developing a lot of the technologies that we use today, and has spent probably the last 20 or 30 years trying to figure out how to teach students at the ages that I teach, older and younger. So it's fun to watch those people going through similar adventures.
Nice. Now, apart from, I mean, you mentioned that you have been teaching Kicks for 15 years about programming over there. Now, over this 15 years over there, and you also mentioned that you have switched several kind of programming language over this 15 years in the previous panel talk. So I wonder what makes you, what kind of things that makes you think that probably, or perhaps I should ask in this way, what is there any so-called the best programming languages that you can use to teach the Kicks? Because right now I have the issue that I'm thinking of teaching my Kicks for programming language, and of course for this age of 6, I'm not too sure whether Python is still a suitable language for him at the moment. Yeah,
Probably not.
So I wonder, is there any best programming language or any kind of suitable language that you can teach Kicks about programming?
It really depends upon what the children want to do with programming, and what kind of computer skills they have. So in the program that I teach in, we use 3 different languages to try to approach the children from 3 different angles. One of the languages that we use is an icon-based blocks-like language, where the children drag icons around on the screen and connect them up with wires. That helps students that don't have strong keyboarding skills be able to succeed in programming. There are a lot of systems like that you might approach for 6-year-olds that are fairly simple, that use icons and don't require the use of a keyboard. At the age that we're mostly focused on, 10 to 12 years old, the students have had a couple of years learning how to use a keyboard. And they're pretty good at the alphabet, and they're pretty good at typing words. They're still very challenged by punctuation. And when I tried to teach the students how to program in C on Arduinos, that was the hurdle we couldn't get over. The students' keyboarding skills were just not strong enough to be able to find all of the punctuation marks and type precisely enough to actually get C programs typed in correctly. It was too much typing, and it was too complicated. So using a language like Python, which uses a lot more alphabetic keys and has much simpler syntax and much less to type and much less to explain about why you're typing these odd symbols, has been a tremendous benefit for the students at this age, where they have some keyboarding skills, but they're not facile enough to program in C. But yes, there are a lot of different programming languages. I can't even think of all of them now that are available on different programming environments. But for programming in robotics, Lego actually sells a bunch of icon-based programming languages that are not too bad. There's Scratch, which is a fabulous environment based on Smalltalk, but it doesn't look like Smalltalk.
Okay. Asking on behalf of the audience, would you like to share a little bit about Project Snakes over there? And when you launched the Project Snakes, it turned out to be quite a big hit in Reddit when I read that before that. So I would like, would you like to share a little bit, Snakes to our audience and how they can participate on the projects to benefit to teaching kids in programming?
Sure. Well, so I had built, as I said, I had been teaching the children how to program in C on Arduino computers, and I had actually built some custom Arduino computers based on the old 8-bit Atmel AT, Atmega 328 processor. But when I wanted to switch them to a more advanced language, I really wanted to stick with very, very simple and easy to understand language. And a very simple computer as well. And I wanted to make it fit on an Arduino. An Arduino has 32 kilobytes of ROM and 2 kilobytes of RAM. It's a very small programming environment. And so the notion of building a very tiny Python appealed to me. I looked at MicroPython and CircuitPython, and both of those languages are much larger. They're very capable languages. But they require much larger computers, and the syntax that they use is real Python, and it's not really customized for the environment that I have, which is these tiny little robots with a few motors and a few sensors. And so I thought a simpler language that was really focused on Lego robotics would be much more approachable by the students. Another important aspect of the Snek environment is that because we use 3 different languages in the program that I work with. We use a Logo language, we use the RoboLab, which is a blocks-like language, and we use Snek. I wanted the semantics of the operation of the robot to be the same between the 3 languages, so they have the same basic operations. You can turn motors on by talking to them and telling them to go on or off. You can read from sensors to find out what the current sensor values are. And then you can do logic in the language to connect those 2 together. But with the semantics of the 3 environments being very similar, it's very easy to teach the children all 3 languages and watch them understand the different programming languages without also having to understand different programming models for the robots themselves. So Snek is a very tiny language. On the Atmel 328, it runs in about 30 kilobytes. And on the larger processors that Adafruit sells, like this one, the Ada Circuit Playground Express, this has a larger ARM processor in it, but Snek still fits with pots of space to spare. I think that device has 256 kilobytes of flash, and Snek fits in like 60 kilobytes or something. It's a tiny little corner. But it's been a fun language to develop. I always like writing new languages, but the focus for the children is the smallest possible language, which gives you a Python-like programming experience on tiny little robots.
Okay, you mentioned about mentioned the keywords over there, 32 kilobytes of RAM, flash memory over there. Now, is there any reasons why you want to choose this kind of embedded board rather than started your projects maybe on Raspberry Pi or anything like.
Well, that's a very easy question to answer. The Raspberry Pi is terrible for connecting to external devices. It doesn't
Okay.
have good interfaces for GPIOs. It doesn't have easy. You can't plug sensors in easily. It doesn't have any motor controllers on it. You can't talk to motors. And if you're building robotics, a Raspberry Pi is a very frustrating environment for the students. Another thing is that it's actually a lot of computer to try to get running. When the students come in to start programming on it, you have to get it booted running Linux, and that takes a long time. And so when it breaks and you have to replace it with another one, it's not a matter of throwing the other one across the room and sliding another one under the student's eyes to swap out in about 5 seconds time. So a very small embedded computer has a lot of advantages in a classroom environment. It's a lot less maintenance and a lot less management, and they're a lot easier to connect to the devices.
Good to know that. Yep. Now speaking back to the Snek again. You mentioned about the icon programming just now. Would that be extended to icons programming? Because right now, when we look at the code.org, that do have the icon-based programming that use JavaScript as the backend. So I wonder, will you have that for Snek as the icon programming?
Yeah, that's an interesting idea. I haven't really considered it. It's not pedagogically required for the program that we're working on because we have a different icons-based programming environment that has, as I said, similar semantics for the robots. But providing that kind of gentle introduction to programming, it definitely has some appeal. I don't know if I'll have time to work on that. It would be fun to see somebody else give it a try. The nice thing about Snek in that kind of environment is that environment builds a JavaScript program by using icons, and so the ability to build a Snek programming using icons and then send that to the device to run it would be a natural extension, and that would give you the web-based programming environment that we talked about in the last session, and get rid of the need for custom Python running on the desktop.
Okay. We have a questions from the audience from Swimming An. He mentioned that is there any physical interface that make it easier for the students to learn it?
Physical interface for the student or physical interface? Oh, does having a physical interface make it easier for the student to learn? Yes. So the program that this programming sequence is a part of starts with building Legos with 6-year-old students, and so after the 4 or 5 years, they come into the programming class having already learned to build sophisticated Lego models. So the students feel a mastery over that part of the program already, and we're adding a small element of programming to their existing knowledge, so they feel they're already empowered. They've already been in the environment. They know the Lego environment well, and so that gives them some sense of mastery before they start learning the programming aspect. So that's one thing. Another thing is that at this age, the students are typically kind of transitioning from a very physical world-based environment, very concrete, to being able to start reasoning abstractly. And so giving them this concrete object, the Lego robots, gives them that ability to try to make that mental leap from concrete thinking to abstract thinking. And so I think pedagogically that's worked very well for the students, being able to step back into the concrete and build some Legos for a while, and then move into the abstract and thinking about how the programs work. So that works quite well. Also, just the ability to get that concrete physical feedback from your programs. Very simple programs can have very sophisticated behavior with robots. Watching something move around the room is a lot more interesting in a lot of ways to watching something move around on the screen. The Python turtle graphics is kind of an interesting example there. How much fun would a student have with a two-line turtle graphics program drawing circles on the screen compared with being able to chase the robot across the floor or having it run into tables trying to draw a circle on the floor? So there's a different kind of learning environment that you can engage more of the students' bodies by having that physical aspect to the environment as well.
Nice, nice. Now, speaking of, you mentioned quite a number of times of the pedagogy approach over there. Now, of course, we would like to know what would be, what would you like to share some about the success story or the fun moment, or maybe the eureka moment from the students throughout your years with programming language, be to be any kind like C or Snake, particularly in this case?
Absolutely. So last year was the first year we really started using Snek in any serious way with the students. The year before, I'd been working developing it with the advanced students, but last year we started bringing it into the younger students' hands. And one of the first week we started using Snek, one of the students was having tremendous success, and her response was, "I love programming. This is fantastic." And that was just such a different experience with Snek than compared with the experience we'd had with C in the previous years, where the students were very frustrated by the programming environment. I also have had students take their robotics experience in grades in ages 10 to 12 and bring them up into statewide science fairs. I had a student build a robot in their last year of pre-college education. They built a robot to automatically track the sun with a solar panel, and they built it out of Lego, and they built it with the little Lego computers that we had, but it was a much more sophisticated algorithm and a much more sophisticated environment. But being able to take the education and the tools they had learned several years earlier and bring that into a science fair environment was very, very gratifying. I have another student, actually my daughter learned programming and Python in the school programs that we taught. And when she got to college, she was able to take all of the Python knowledge that she learned and apply it directly to her geology degree, because it turns out that all of the geographical information systems, the GIS systems that she used in school, are now directly programmable in Python. So teaching students before they get to college how to use Python readies them for an education in almost any field that involves technology. And probably the last one is an interesting one. I had a young friend of mine got an undergraduate degree in astrophysics and learned Python in high school and went off to college. And in her sophomore year, after her sophomore year, the professor was looking for somebody to come do some data reduction in Python over the summer. And she was like, "Oh, I know how to do Python." And so because she was the only student in the astrophysics program in all 4 years, none of the seniors were that advanced in Python. Because she knew Python, she spent the summer at the radio telescope in Puerto Rico called Arecibo doing data reduction in Python. So if you've ever seen the James Bond movie with the villains running around on the catwalks at Arecibo, she's been there.
Okay.
And she got there because of Python.
Very, very inspiring story. Now, of course, we know that Snek is a very interesting language that you have developed. Now, do you have a roadmap for Snek? And also another question, maybe this is kind of provoking questions. So would you see Snek as a compatible or competitor of MicroPython, CircuitPython, since both dialects comes from the same parents, Python?
Not at all. I actually have a good. I've actually talked for a couple of hours with Scott, one of the key CircuitPython developers, and they're very, very, very compatible languages, and one leads naturally into the other. In fact, the Snek, most of the hardware that can run Snek today can also run CircuitPython. Snek is really designed for that very first programming experience where the students have limited keyboarding skills and very limited exposure to computer programming at all. It's the gentlest introduction to programming that I could provide. It's a very small language. It has no objects. It only has 2 data types. It has numbers and strings for the basic data types. It also has tuples and lists and dictionaries, of course. But very, very small language, and so it only takes a couple of hours to teach the entire language. But the result is that it also is very limited in what it can do. You can build robots out of Lego very effectively in Snek. You can connect a wide range of analog sensors to the input ports, and you can connect motors to the motor controllers. But if you want to connect a temperature sensor, or if you want to connect a 3D accelerometer, it doesn't have support for those. It's not a general purpose embedded programming language like CircuitPython is. So CircuitPython, from my viewpoint, is the ideal successor to the Arduino programming environment. I think it can do everything you can do with an Arduino, with the Arduino in C, and it's a great way of getting people off of the C language and onto a much more accessible and debuggable and a language that's going to take them a lot further in computing, getting them to Python. So I would like to see Snek as a way of introducing students to Python very gently at a very young age, and then taking the skills that they learned with that very small language and moving into CircuitPython on other embedded projects, or moving on to Python on the desktop or on the web for programming in those environments. But learning Python the whole time.
Okay, so we still have kind of 3 minutes, and it seems like we don't have any questions from the floor. So, okay, perhaps we will end with this question over there, which also something that I would like to ask myself. Actually, 2 questions. What are the greatest moment and greatest setback throughout your career? And another question is, if you have a chance to travel back to your 20s to 30s, what advice would you give to yourself at that time?
Yeah, I've had an enormous number of fantastic experiences in computing. Certainly, the kind of the big step change in my career was certainly deciding to go do 4 years of research at MIT building the X Windows system. The people that I met there, the opportunities I got to travel the world, and the opportunities I got to spend with some of the smartest people I've ever known were just fantastic. That was a big risk that I took moving across the continent to join a group of people I'd never met, live in a place that had actual winter, but I would do it again. Probably the biggest setback was working with the x386 community and realizing that community was so dysfunctional that it needed a kind of a traumatic event to occur to it, and that was pretty painful. And advice to my younger self: yeah, keep writing, keep talking, and take care of your friends.
Thank you. Let's see whether we still have any questions from the floor. Yeah, I don't think we have any things from the floor. Perhaps we can end this session with maybe what would be your advice would like to give to the young programmers or maybe junior programmers, so that keep them motivated all the time, like I mean throughout your experience, because all of us from here, we grew up as a junior programmers, junior software developers, and then we grow as a seniors and eventually becomes professionals. So maybe a few words for the juniors software developers.
Absolutely. So it's probably similar advice that I give to students at university. What you do is not nearly as important as who you're doing it with. So at university, if you find a fantastic professor that teaches well and is engaged with the students, it almost doesn't matter what topic they're teaching because you're going to learn a lot from them. Similarly, in programming, find people that you want to work with and go do whatever they're doing because they're doing it for a reason. And no matter what they're doing, you're going to learn an enormous amount. So follow the people that are going to teach you. And then, of course, as you learn more, it's important to teach other people what you've learned, both to pass along the knowledge to people with less experience, but also to make sure that you understand it very well. The best way to know that you have learned a topic well is to be able to successfully teach it
Cool.
to somebody
Okay.
else.
Okay, we got very last question that we have from the audience. So this is from Igor, and he mentioned about if we need to learn circuitry well enough so that to programs the embedded system. Yeah, maybe this is just the last question from the audience. Yeah.
Sure. So one of the nice things about systems like CircuitPython is that a lot of the examples, a lot of the systems come with fairly canned examples of what you can do, with existing sensors, and so it kind of shows you how to wire things together. So you can kind of learn by example. So I've done a lot of embedded programming with students that are just plugging sensors in that they bought from the net that are designed to work together, and so it's pretty easy to learn by example.
Okay. Thanks, Keith, for the interview. We certainly have learned a lot from you. Thanks for the session, and hopefully to see you again in person or in others sessions. Then,
I sure hope so. Thank you so much for taking time
thank
to
you,
speak with me today.
thank you, thank you very much, and thank you, and see you,
Bye-bye.
audience. Bye bye.
Microsoft is delighted to be at PyCon. Hope you are enjoying the sessions. Scan the QR code to join the Microsoft developer community and receive regular updates on many open source topics, including Python.